In this video, we will learn about the perfectly elastic collision. For a short time period, when two or more bodies exert their forces on each other, it is termed collision. Collision can be elastic or inelastic in nature. Elastic being the one in which there is no loss of kinetic energy, and inelastic being the one in which the kinetic energy is transferred to some other energy. Mr. Atul Malhotra from Puran Chandra Vidya Niketan, Kanpur will tell us more about this topic.
Today we will study the next topic of the physics, that is collision. The first part is perfectly elastic collision. Suppose there is a body of mass m1 is moving with the velocity u1, strikes another body of mass m2 moving on a same straight line with the velocity u2. Let us say the u1 is greater than u2, it means both the bodies will collide each other, and after the collision let their velocities are v1 and v2. Right now we are discussing about the perfectly elastic collision. So for the perfectly elastic collision, the coefficient of restitution, symbol is E, is equal to 1, and it follows the following laws. First one is, it follows the law of conservation of linear momentum. 2, the kinetic energy remain conserved. Third, total energy remain conserved. So now we will derive a relation between velocity of approach to the velocity of separation for perfectly elastic collision. The first, following the first law, that is the law of conservation of linear momentum, we can write it as total momentum before collision is equal to total momentum after collision. Second, the kinetic energy remain conserved. So we can write it as half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. Write it the above equation as question number 1, and this is at second. Now we collect the terms containing the m1 on the left hand side in both the equation and m2 on the right hand side on the both equation. So for the first equation we can write it as m1 u1 minus v1 is equal to m2 v2 minus u2. This is the equation number 3. From the kinetic energy equation we will cancel the terms of half, and when we collect the m1 on the one side we can write it as m1 u1 square minus v1 square is equal to m2 v2 square minus u2 square. This is equation number 4. Now we divide the equation number 4 by the equation number 1. So we can write it as m1 v1 square minus u1 square is equal to m2 v2 square minus u2 square upon m1 v1 minus u1 upon m2 v2 minus u2. Now cancel these terms and use the identity of a square minus b square on both the sides. We can write it as v1 minus u1 v1 plus u1 upon v1 minus u1 is equal to v2 minus u2 v2 plus u2 upon v2 minus u2. Now cancel these terms and now we get v1 plus u1 v2 plus u2, or we can write it as u1 minus u2 is equal to v2 minus v1. It means on the left side we can find that is the velocity of approach, difference between the velocity of approach is equal to the difference between the velocity of separation. Now in this topic we will find the velocities of two bodies after the perfectly elastic collision. So we have to calculate the value of v1 and the value of v2. In the last topic we have studied about in the perfectly elastic collision the velocity of separation is equal to the velocity of approach. Find the value of v2 from this equation. We can write it as v2 is equal to u1 minus u2 plus v1. Now put this value in the first equation, that is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. When we put this value in this equation, then we can obtain m1 u1 plus m2 u2 is equal to m1 v1 plus m2, we can write it as u1 minus u2 plus v1. Now collecting the terms of v1 on the one side and the rest on the other side, we can find it as m1 u1 plus m2 u2 m1 v1 m2 u1 minus m2 u2 plus m2 v1. By solving it we will get v1 is equal to m1 minus m2 upon m1 plus m2 u1 plus twice m2 u2 upon m1 plus m2. This is the result for obtaining the velocity of first object. Similarly, we can find the velocity of second object, that is v2 is equal to, in the place of 1 write 2, in the place of 2 write 1. So we will get it as m2 minus m1 upon m1 plus m2 u2 plus twice m1 u1 upon m1 plus m2. By finding these two velocities, we can solve all the numericals, such as how much the energy will be transferred from one body to another body during the perfectly elastic collision, what percentage of kinetic energy is retained by the first body, if there are different cases, if the masses of bodies are identical, then the velocities will interchange.
The relation between the initial and final velocities is given by v1 equal to m1 minus m2 upon m1 plus m2 into u1 plus 2m2 u2 upon m1 plus m2, and v2 is equal to m2 minus m1 upon m1 plus m2 into u2 plus 2m1 u1 upon m1 plus m2.
In this topic, we will find an answer that during the perfectly elastic collision, if both the bodies are identical, then their velocities will interchange. In the last topic, we have find the expression of v1 m2 upon m1 plus m2 u1 plus twice m2 u2 upon m1 plus m2. Suppose the mass of both the objects are same, m1 is equal to m2 is equal to m, and the velocity of first object is u1 and the second is u2, and they are moving in the same direction. So by placing these value in the above formula, we will get m minus m upon m plus m u1 plus twice m2 u2, we can write it as m, this is m plus m. So the v1 is equal to 0 plus twice m u2 upon 2m. It means v1 is equal to v2. Similarly, we can write v2 is can solve v2 is equal to v1.
For perfectly elastic collision, the coefficient of restitution is 1. It follows the law of conservation of linear momentum. The kinetic energy remains conserved. Total energy also remains conserved.
For more such videos, log on to CBSE section of jagranjosh.com.